Did you know that there's a wild math theorem that says you can't comb a hairy sphere flat without getting a cowlick? Yup, you heard that right. Welcome to the world of the Hairy Ball Theorem, where mathematics meets some seriously funky ideas. So, what exactly is the Hairy Ball Theorem? Well, it's a fascinating concept in topology, which is a branch of mathematics that deals with the properties of space that are preserved under continuous transformations. This theorem gives us some mind-bending insights. It essentially states that if you have a hairy sphere, you can't comb all the hair flat without creating a cowlick. It's bizarre and totally counterintuitive, but it's a crucial part of understanding how certain shapes and surfaces behave mathematically. Now, let's dive into the challenge presented by this theorem. The Hairy Ball Theorem states that it's impossible to create a continuous, non-vanishing tangent vector field on even-dimensional spheres. Whoa, that sounds complicated, right? But hang tight. In simpler terms, think of it like this: if you were trying to comb the hair on a beach ball, you'd eventually hit a spot where you just can't get it to lay flat without some hair sticking up. That's because there's no way to smoothly distribute the hair across the surface without leaving at least one tuft standing up. This challenge is rooted in the properties of even-dimensional spheres, and it has some pretty wild implications in both pure and applied mathematics. Now, let's explore this idea a little deeper. In topology, a vector field is a way of assigning a vector to every point in a space. When it comes to spheres, we're usually dealing with surfaces that can be a bit tricky. So, when we talk about the Hairy Ball Theorem, we're really discussing how these vector fields behave on spherical surfaces. This theorem isn't just a fun mathematical curiosity. It has real-world applications in areas like fluid dynamics and computer graphics. For instance, when simulating water flow or creating realistic animations, understanding how these vector fields work is crucial. Imagine trying to model the flow of water around a beach ball. If you can't get the vectors to behave properly, your simulation is going to look pretty unrealistic. But let's get to the juicy part. One of the coolest ways to visualize the Hairy Ball Theorem is through a simple experiment. Imagine you have a globe with hair sticking out in all directions. Now, take a brush and start trying to smooth it out. No matter how hard you try, there's always going to be a point where you just can't get the hair to lay flat. This visualization is more than just a cute analogy. It demonstrates the theorem's implications in a tangible way. Whether it's the airflow over a sphere or how we understand the shape of our universe, the Hairy Ball Theorem shows us that some limitations are just baked into the math itself. So, to wrap things up, the Hairy Ball Theorem is a unique and mind-bending concept in mathematics that reveals some pretty strange truths about how we understand shapes and surfaces. We've seen how it challenges our intuition and has real-world applications in fields like fluid dynamics and graphics. It's a prime example of how math can be both weird and wonderful, showing us that sometimes, things just can't be neatly smoothed out. Now, I want to hear from you. What did you think about the Hairy Ball Theorem? Do you have any questions or thoughts? Drop your comments below. And if you're curious to learn more about other quirky mathematical concepts, don't forget to check out my next video. Thanks for watching, and keep exploring the wonders of math.